We study now equal functions. Suppose you have two functions given fx and gx. Now any two functions fx and gx will be called equal if the domain matches exactly with each other, and also fx or the range of f should be exactly equal to gx or the range of g. To explain this further, let's assume that there is a set A which has three elements -1, 0 and +1. Assume there is another set B with two elements 0 and +1. Now what we do is that we define a relation between elements of A and B. In other words, you can say there is a function f being mapped from elements of A to B. Naturally A will be then the domain of this function and B the range, and assume that we say that this functional relationship between domain elements and the range is fx is equal to x square. So x will be the elements from set A, the domain, and fx will be the elements from B, the range. Now when we consider first element of A -1, then this -1 is related to element of B through this relationship, and B therefore element in B that is related to -1 will be this 1 here. Similarly, the 0 of A will be related to 0 of B, and +1 of A will also be related to +1 of B. Now if you are given another function g and the relationship between A and B is not defined by the formula fx is equal to x square, but by a different notation wherein it says that g function of -1, the element A -1 with g is related to +1 of B, the element 0 of A with g is related to 0, and element 1 with g is related to +1 of B. Then what we see is that g function also relate -1 of A with 1 of B, with 0 of A with 0 of B, and +1 of A with +1 of B. That means the domain of G, which is -1, 0 and 1 given by set A, is same as domain of F, which was -1, 0 and 1. Similarly, the range which was expressed here as +1, 0 and 1 is also exactly same here. So function f and g are equal. Both domain expressed by set A is equal, as well as the range expressed by set B is same for both f and g. Let us now replace set B with set C, and we introduce a new element +2. So C is 0, +1 and +2, and see what happens now with a new relationship called a new function h from A set to C. Our definition of function f remains the same as the previous case. F is a function from A to C and is given as fx is equal to x square. Therefore, when you put value of -1, so f of -1 will be equal to +1, f of 0 will be equal to 0, and f of +1 from set A is equal to plus 1. That means that the relationship here is from minus 1 of A to plus 1 of C, 0 to 0 of C, and plus 1 again plus 1 of C. Now this element is left. So the range is 0 and 1 when you have connected from A to C, but 2 is left, therefore 0 and 1 will be the codomain. 0, 1 and 2 will form the codomain. Now any relationship where there is a difference of codomain will not affect equality of function, because the two things that are required is that domain of two functions and the range of two functions should be same. So it means that if h function is a function between A and C and relates these three elements minus 1 to 1 of C and then 0 to 0 of C and plus 1 to plus 1 of C, then the two functions f and h will be same, though there is one element left in the codomain, but that is not affecting our two conditions. Our condition 1 was domain should be same, so domain of h function is minus 1, 0 and plus 1, and range of h function is also 1, 0 and plus 1, which is the same as the range of f function. So the two functions, even though one element is left and is actually part of the codomain, but because domain and range are equal, therefore the functions will be equal. Remember, equal functions are also known as identical functions. Suppose you are given two functions f(x) is equal to x and gx is equal to root of x square, and you are supposed to find whether the two functions are identical or equal or not. It says that x, the number x, belongs to the real number. Now what does this mean? The real numbers can be thought of as points on an infinity long number line. So if you have 0, positive side is 1, 2, 3, 4, 5, 6, 7, 8 till infinity, and negative side is minus 1 till minus infinity. A real number is any point anywhere in this line. It could be fraction or anything. So fx is equal to x. That means domain of fx is any number on this line, positive or negative. Similarly, domain of gx is x, which is any number on positive or negative side. However, when we see the range, fx in one case is x. That means when you take any negative value of x in the domain, you will get negative range also, and when you take positive value of x in domain, you will get positive x. Whereas when you see this, what we know is that square root operation on real numbers is always positive. That means this operation will yield a positive real number. So if you put any positive number here, then the range will obviously be positive. But interestingly, if you put from domain any negative number and put here, then square of negative number is positive, and when you square root, then you get a positive value finally. That means range of gx is just the positive side of this number line, whereas domain of gx is full line. Again I repeat, because square root operation will only restrict this to positive thing, therefore range is limited to positive thing. Therefore the two functions, though they have same domain, which is complete number line, but the range of first one is full number line, but the second one is just the positive side. Therefore domain though equal, but range since are not equal, therefore the two functions fx and gx are not equal functions.